All right. Hi everyone, and welcome to this session called What's Changing and What Hasn't About Commercial AI. So, by way of introduction, my name is Richard Zuroff. I'm a director of AI success here at DataRobot. And for those of you who maybe haven't heard of DataRobot before, we were founded way back in 2012 as really the category creators for AutoML. And since then, we've grown dramatically through over $1 billion in funding to employ 700 plus data scientists and engineers, serving 1,000 plus clients in nearly every industry. And that journey actually provides the framing for my agenda today. So as a company, we've grown and evolved alongside the market. And in reflecting on that growth, we see some things that are still true, but also some things that have changed in that time. So I'm going to share some of those insights. And then I'm going to end by taking a look forward to extrapolate a little bit about what we expect to see next. So going back to DataRobot as a company for a second, we started out by trying to help one set of users do one thing. So we enabled data scientists and citizen data scientists to build models more quickly by providing automation and guardrails. But we recognized that our customers needed more to truly get value from their data. So we've expanded our focus. Now, as a company, we really cover the end-to-end life cycle, from data prep all the way through model building, deployment, monitoring, and consumption of those predictions. And in doing that, we provide a single platform for creators of models, but also operators like IT and consumers of predictions like business analysts and executives. So we now have a much more holistic view of what the challenges and opportunities are for an organization looking to create value with AI and big data. And so within that journey and within that life cycle, we see some things that are still true, no matter whether an organization is just starting out like we were, or is getting towards the more mature end of the curve. There we go. So there are really three things that stand out as still being true, and I'll talk more about each of these. The first is that you still need to identify the right use cases. Having identified those, you need to start small and build capacity over time. And you need to be aware while you're building of the particular risks that come with AI. So let me talk a little bit more about each of those in turn. So now, every AI journey and AI program has to start with identifying the right use cases. Otherwise, there's a risk that using the technology just turns into a series of science experiments. And in looking for good use cases, an organization can ask itself three questions. So first, where is there uncertainty about the future? AI and ML models output predictions, and predictions are valuable if they can help you make better decisions in the future. But if you can't articulate what you would do differently with better insights, then it's probably not a good use case. Second, organizations can ask, where will a small change make a big difference? So it's sometimes really hard to know beforehand exactly how powerful a model will be. And you want to avoid this catch-22 of needing what the end is going to look like before you start. So to do that, what you can instead is look for large pools of value. So maybe things like the early stages of a funnel or a process, where even a small improvement will probably be worth the effort. And third, you can ask, where is time or human attention or human capacity a bottleneck? Now, most AI applications are about augmenting and not replacing labor. So you can look at low value tasks where people are spending their time today, and those are sometimes good use cases. But it can be even better to look for the tasks that aren't being done at all because of a lack of human time or capacity. And if you are asking those three questions, then you'll probably be coming up with good use cases. So now, if you're asking all of those questions, then almost any organization is likely to find dozens, if not hundreds, of potential use cases for AI. They tend to exist in every function and every department somewhere. And the result is that what's still true is demand for AI will almost always grow faster than your ability and your budget for hiring data scientists. And this means that it's important to look for other groups like software engineers or even other subject matter experts that you can empower. Otherwise, you risk missing out on a lot of opportunities. Now, in building that capacity and executing on those models, you still have to be aware of the fact that AI and ML has some fundamental differences from rules-based programming and traditional statistics. So first, what's different is that modern ML learns features rather than having them hand engineered. And that learning can create a range of risks from technical issues like target leakage to more social issues and problems like proxy discrimination that's in the news rightfully quite a bit. The second thing that's different is that many AI and ML tools operate not just on structured databases, but unstructured, so text, images, sensors, and videos. And these types of inputs are very high dimensional in terms of both the input and the output spaces, which gives a lot of room for these learning algorithms to explore, which is great and why they're so powerful, but it also means that it's difficult or impractical to test for everything in traditional ways, and that creates its own risks. And finally, because of these learning patterns in this space that's being explored, systems that learn aren't as deterministic as traditional ones. They can adapt, they can continuously learn, which is tremendously valuable, but that continuous learning can also create challenges from training all the way through to operations. So things like replicability, trust, adoption are all more challenging in an AI ML space. So that's what's still true. Let's talk a little bit about what has changed. So one of the first thing to call out is that the cost of experimentation is lower than ever, and that it should impact how you're thinking about the strategy. The second thing that's changed is that unlike in the past, today, and especially going forward, a better algorithm generally isn't a competitive moat. And the third thing is that, and I'd mentioned some of the risks just now, we're starting to have a little bit more clarity about what good governance to manage those risks look like. And so I'm going to talk a little bit about each of these. So at DataRobot, we've worked with lots of customers and we see them go through various stages of maturity. So if you're just starting out on your first AI project and it seems like difficult and challenging, that's not an uncommon feeling. But it's important to resist the conclusion that because the first one is difficult, that it's really then the consequences we should carefully engineer like a grand top-down strategy and spend months or years vetting individual projects. Our experience is that with practice, organizations actually get a lot faster at building, thanks to automation, they can try a lot more approaches. So, over the last couple of years, the cost of experimentation has gone down. So it's less important to find that one killer use case than it is to continuously build the muscle of delivering over and over again. Linked to that is the idea that your most important differentiator as an organization is likely to be the speed at which you can iterate and get models in production, not whether you have a marginally better algorithm than your competitors. And the reason I say this is you can kind of see it coming out of the research side. So new models like GPT-3 are introduced and show massive improvements on benchmark tests for a few years. That's what you see on the left-hand side of the chart. But we also see that performance flattens out over time as algorithms become good enough. And although it might make sense for the Googles and Facebooks and Amazons of the world to invest in pushing the absolute cutting edge forward, as an organization that isn't one of those, you really need to ask yourself, do you want to spend something like $12 million building the next GPT-3 or pennies using it for something? Now, especially as you grow to have more and more models and opportunities identified, it's almost always more valuable to get to the next use case, to go, from 0 use cases to 5 use cases, all operating, at a pretty good level, let's say 80%. And that's going to be more valuable than just focusing on one application and pushing that forward, getting that from 98 to 99. Now, if we go back to the risk side, and we look back a few years, the initial reaction from companies and policymakers to recognizing those risks was to produce a lot of AI principles. And you can see the number of AI principles, growing over time that were published. But that era is coming to an end. And you can see sort of the drop off now in the number that are published each year. And what we're instead seeing is actual regulation instead of these self-published principles. So in Canada, for example, we have Bill C-11, which is incorporating certain aspects of GDPR, as well as traditional regulatory leaders like the EU and their AI Act. And even players like China that are showing much more interest in tech regulation recently. So all in all, we see this general shift away from principles more towards practices and actual regulation. So that's a quick summary of where we are. And I think it's useful in the last little bit of this talk to say, based on that, where do we think we might be going? Now, like everyone else, I don't have a crystal ball, but I can guess at 3 trends in big data and the AI space that I think organizations should be positioning themselves for. One is that no code and low code will continue to spread and cover more of the AI and ML lifecycle. The second is this idea of foundational models and other improvements will continue to accelerate the benefits of reuse. And the third portion is, again, thinking about risk and now governance, and now thinking about having the tooling to actually implement and scale some of those governance practices. So this is an extremely busy chart, and really the only point of this is to say that we see tons and tons of no and low code platforms branching out into almost every area. Now, for those who are less familiar with it, low-code platforms is just a name for tools that automate and abstract some of the underlying complexity of some sort of a process so that non-specialists can do more. And this is a big trend across, as you can see, almost every piece of the tech stack, and you see lots of players entering into this. And given that we see this happening almost everywhere else, I think it's reasonable to assume that this is also going to come to the AI and ML tool chain. There isn't an a priori reason why our area would be exempt. Now, it's true that some of the hardest things to automate are interfaces between systems and the real world, where subject matter expertise, business logic, and context are critical. But I still expect to see citizen developers and data scientists being able to do more than they were in the past, thanks to some of these no and low code tools. So things like not just preparing and building models, but also potentially spinning up some of those consumption layers that happen towards the back end. Now, one of the things that I mentioned in the previous section is that the ease of experimentation has gone up. And I think that type of a trend of reusability is likely to continue. So the research community has recently coined this term of foundational models. So these are single models like BERT that can be pre-trained and then applied to a variety of tasks, rather than using a generic architecture like CNNs, and then taking that and applying it to build custom systems for each task. And what we've seen is that this approach has been really successful in certain domains. So with things like natural language processing. Previously, the best score that a custom system could do in something like answering 8th grade science projects was 73%, but a foundational model sort of immediately scores 92%. And so because of that success, we expect to see more of it getting used. Researchers are going to want to replicate that to find BERT for vision and BERT for planning and BERT for reasoning. And why that matters if you're not necessarily a researcher, but a business person, is that as a business, you won't necessarily need to throw your R&D teams into that effort. You can focus on reuse. So when they do get rolled out, they're, again, these generic models, single models that can be used for lots of different tasks. So you can say, how do we have the infrastructure and modularity and optionality needed to take advantage when these things are developed and use them to the greatest effect for our business? And finally, I mentioned that regulation is here and has taken over from sort of these non-binding principles. But understandably, the technology for compliance hasn't necessarily kept up at the same rate. So if you look at one example, like the EU AI Act, it includes a variety of requirements, and you can see that continuum on the page. So some of them are more numeric, like testing your models for bias. And some of them are more procedural, like documenting the risk management system that you have in place. And today, there is tooling that can help with the more quantitative tasks, like assessing the robustness of your system. And in the future, what I would expect is to see more tooling around the procedural side and platforms that have integrated governance so that your compliance costs are growing less quickly than your usage. So I'm almost out of time, so I'll just close by saying I hope this has been helpful. And if you remember anything from this talk, there's 3 takeaways. So first is that if you manage to ask those questions at the beginning and pick good use cases, then that will create more demand than you likely have supply of data scientists. And so if you have that problem, and it's a good problem to have, use automation and tooling to let subject matter experts apply their business and domain expertise. And also, if you're a data scientist or you have data scientists, spend that focus on the hardest problems. And that division of labor can be really powerful. The second takeaway is focus your people, processes, and technology on getting to value as quickly as possible. And the way to do that is to be able to quickly reuse and combine the best existing pieces, whether that's data or pipelines, things like foundational models, open source, whatever it is. Learn how to reuse and combine rather than necessarily building from scratch. That's the organizational capacity that I think will be a real competitive moat rather than just the fanciest algorithm. And the third takeaway is that rule and policymakers increasingly have converged on some of the what requirements. So what do we need in terms of safety and fairness and explainability and oversight in order to manage the risks that come with AI? But we haven't really seen them specify how. And that space of how leaves lots of room for tooling around audit and risk and other process-focused roles. So I think that organizations that really embrace those aspects of risk management can use that as a path to making AI more scalable. So with that, I will finish the talking portion. Let me just get to the last slide. There we go. There we go. We'll open it up for questions. So feel free to ask questions in the chat, or if not, then feel free to get in touch either with me or with DataRobot directly. You can see the contact on the screen. So with that, thank you very much, and I will stop here.